Let's see how well you did on our two prime factor problems. The first one is to prime factor 66. So we'll go ahead and make our prime factor bush. Now there's two ways we could do it. We could notice that this ends in an even number, and as a result we can divide by 2, and 2 will go in evenly into 6 and 6 and give us 3 and 3. Well, 2 is a prime number, but 33 easily can be seen to be containing a 3 times 11. Both of these are prime numbers as well. So the 66 is 2 times 3 times 11, and our answer would be C. Now, 6 times 11 would also work as our answer. However, the number 6 is not a prime factor, so it could not be the possible answer to this problem. Just to go along with this 66, if we went 6 times 11, broke it up that way, then we could further break the 6 down into 2 times 3, yielding the same result of 2 times 3 times 11, which is answer C. Now, our second problem dealt with the number 175, and we could break this up in a couple of ways as well. Firstly, it ends in a 5, and as a result, we can pull out the number 5. And 5, if we divide the long division into 175, 5 times 3 is 15, and that will give us 2 as when we subtract. Bring down the 5, and 5 goes into 25 5 times evenly. So 5 times 35 is 175. 35 is 5 times 7. So what we are left with are prime numbers of 5 times 7, or 5 squared times 7, and that would be answer D. Another way we could look at this is we could think of money. 175 is like $1.75, and I do know that lots of quarters, enough quarters, will make $1.75. So if I take 25 and I divide it into 175, this goes into here. Let's try 7. 7 times 5 is 35, and 7 times 2 is 14, and 3 is 17, and this will go 25 times 7. The number 25 itself is a composite number made up of 5 times 5. So we have 3 prime numbers, 5 squared, because there are 2 of the 5s, and 1 7, once again yielding our final answer of D.